Hi, my name is Bhumanand Barik and welcome to my YouTube channel. Today we will be continuing discussion about linear regression. Yesterday we have seen how linear regression works. So today we will look into in depth of best fit line, how the best fit line of linear regression works and what is the math behind it. So let's continue. As you can see on the screen, the graph is plotted, and here to find out the best fit line, here as we can see, to find out the best fit line, first we need to understand what is the error. Error is something like the difference between observed price and actual price. Here y is known as observed price and y cap is known as actual price. As an example, we can say, suppose we have estimated the house price has to be 30 lakhs, but we have seen actually the house price is 30 lakhs, but when the algorithm is applied, that time house price seems like something 50 lakhs. So here 50 lakhs is appearing, here 30 lakhs is appearing. So the error is here error is here 50 lakhs minus 30 lakhs, 20 lakhs error is appearing. So this is known as residual also, and this is what called as the distance. So this distance has to be minimized, and it has to minimize for each and every data, every point. So there are various points are appearing. As on the data is growing for each and every point, various points are appearing. So the distance has to be minimized from every output. So when we find a line which is observed in the minimum distance from all the points, that line is known as best fit line here. So we can observe the mathematical formula for this linear regression. Error is known as here y minus y cap, where y is observed value and y cap is actual value. Actual value means the value which we are estimating, and y is observed value. So if we find the distance between y minus y cap, then we can find the error or residual. So mathematically, a cost function is required to know the best fit line, and the best fit line is selected by checking the minimum distance of the points to the line. So the minimum distance has to be checked and best fit line has to be calculated. But to calculate the best fit line, mathematically we can say a cost function is required. So the formula of the cost function I will write on the screen. As we can see on the screen, the cost function is 1 by 2n summation of I equal to 1 up to n and y minus y cap whole square. So here square is required, as we are trying to find here sum of residuals, and square is required just to minimize the negative value. So suppose the value came like minus 5 or minus 4. So if square is done, then at least it will be like 16 or 25. So the negative value will be omitted. So once negative value will be omitted, at least we will come to know what is the difference, what is the error. If negative comes, then it can lead us to a different way. So to minimize the negative, the square is made. And the meaning of this is summation. So here I equal to 1 to n. It means I equal to 1, then I equal to 2, then I equal to 3. Like that it will go up to n value. Let's take here m equal to 1 and c equal to 0. So the value will come if when x equal to 1, suppose y cap equal to 1, x equal to 2, y equal to 2, y cap equal to 2. Like that we can say as we have seen on the screen, like the expression can be written in this way, like 1 by 2n, and if we expand y minus y cap square, it will be something like 1 minus 1 square plus 2 minus 2 square plus 3 minus 3 square. As we are getting the same value as x equal to 1, so y equal to 1. If you search in YouTube or in internet, you can find there are some of the examples on which like y cap is the estimated value and y is the observed value. So if we calculate the sum of residuals in that y minus y cap, we normally try to fetch. Ultimately we are trying to find the error. Error means the distance between y and y cap. So it should not be negative. So here, as we can see on the screen, for one data point we found one point here for one x and respective y. One more point, for one more point we found one more point and respective y. So like that, there are different points we have received. For all these points, various m value is calculated. For all these x values, respective y values we have found, and various m values we found, m1, m2, m3, like that. So as we have seen in the formula of sum of residuals, it is something like this one. So here, for each m value there is a cost function, and the cost function is represented as j of m. So here j of m is cost function and m is the slope. If we plot the graph between m value, which is like in x-axis, m value which is slope, and cost function j of m which is in y-axis, then the graph is something like this. This is the graph which is observed. This diagram is known as gradient descent. This is known as gradient descent, and this point which is touching the x-axis, this is known as global minima. This diagram is required, or this graph is required, because for each, when m value changes, that time cost function also changes. Suppose m value changes from 1 to 0.5, that time cost function also changes. So that time if we calculate the sum of residuals y minus y cap, the value changes, y value changes, and y cap value also changes. That's why like suppose here the value was like in y-axis, the value was like 1, now the value is 0.5. so our estimated value is something like 1. So 1 minus 1 used to be 0. Now the value will be something 0.5 minus 1. So the respective value will come, it's not 0. Like a respective value will come 0.5 minus 1 whole square, like that it will come, and the sum will come for all the m values. ultimately this parabola is formed when the graph is plotted between m and cost function. So here, as we can say, the parabola is known as gradient descent, and the point which is extremely nearer to the x-axis is known as global minima. So the point which is extremely nearer to x-axis, that point is nothing but one m value, and that m value is required to form the best fit line. So as this is the global minima, so this is suppose 2, and respective cost function is something j of m. This m value is 2. So when m equal to 2, this m value can create the best fit line. So the best fit line, so here m equal to 2. So when we calculate our value equal to y cap mx plus c, m equal to 2 here. 2 here for corresponding x, whatever the x present for this line. So for all the x value we have to calculate m as 2. So mathematically it has to be understood how this convergence theorem works. Convergence theorem means the formation of this gradient descent. Here, as we can see on the screen, once m is calculated, for next m this formula will be applicable, which is known as convergence theorem. Old m value minus differentiation of old m value with respect to old m value. So this differentiation, like this difference has to be calculated, which will be multiplied with 1 alpha. So here this is known as learning rate. So here the value del of m by del of, here as we can say, this is derivative of m with respect to m, like and this is learning rate. Learning rate means here learning rate will be very small, like 0.001, like this. It has to be very small. So this derivative is basically the slope. So here, if here slope is negative, it means m minus negative of slope, it is something like m plus positive into learning rate. So it will be something like m plus positive into a very small value, which is a positive. So here slope is negative means it is coming down like this. Slope is positive means it is going up like this. So if the slope is coming down, like let me draw the diagram properly. If this slope is calculated, if it is coming down, it will have negative value. If it is going up, it will have positive value. If equal to positive, so m minus positive into learning, so it will be m minus negative value into learning rate 001, so it will be a negative value. So in this case we can say when the slope is negative it will come down, when the slope is positive it will go up. So ultimately we can find our global minima. So here the question is, why this learning rate is very small? Why it is not too big, or why it is not little big? Because the new m, when m is updated, suppose m is updated by this formula, so this new m again will come here, and again it will be the derivative will be found here. So again and again this new m value will be calculated. So again and again varieties m value will appear. So as the m value gets updated, so we get new m value, and the further the m value is like again and again calculated based on the convergence theorem. If we are, suppose if we are giving a very standard like learning rate, suppose it is not 001, it is something like 1. So in this case, directly from here to here it will come. It is not updated like this. A very small increment won't happen. So at each point it won't check. So here what happens, a very noisy line is formulated. So if the noisy line is formulated, the graph becomes like this. So here it is very difficult to understand what is the global minima. If global minima is not found, then it is very tough to find the best fit line. So this is all about this linear regression, which is part 2, which is already completed. We will learn about the advantages and disadvantages of this linear regression, and what is the in counter of those disadvantages, what are the different algorithms which came up with different advantages. Thank you so much. Like and subscribe this channel. Thank you so much.